but I need you right now for the next 40 minutes or so to be focused in this classroom. Okay? That means I need your chit-chatting to be to a minimum. I need your focus right up here. Okay? So we worked on this warm-up problem. Many of you felt great. Some of you were not quite sure, and I want to walk through it to make sure that everybody's feeling fantastic. So can somebody get me started? During one trial, so you remember we did this yesterday, right? We rolled the bowling ball out in the hall. During one trial, the ball traveled 6 meters, and it took 3.5 seconds to do that. Okay, do you remember this? We were out in the hallway, it went down, yep, okay. The question says, shh, I can't talk over you, friends, so please. What was the ball's speed in meters per second? So for some people, you're like, well, I don't know how to find speed. But the secret is that you really do. You really actually do if you work on this and think about it. Meters per second. You have one measurement in meters and one measurement in seconds. So can you find the value of meters per second? Holy cow, you totally can. Let's leave those rulers down now, okay? Thanks. All right, so let's do it. Here it comes. 3.5 meters in 6 seconds. You can do that division. Oh, I did it. Oh, I'm sorry. I got excited. Thank you for catching me. 6 meters in 3.5 seconds. It's all good. We all make mistakes. 6 meters, 3.5 seconds? 1.7. 1.7, thank you. 1.7 meters per second. I love the fact that people get excited and want to cheer each other on, but it's really distracting for people, especially I've been in this spot a lot of times where I'm just really trying to focus and pay attention so I can understand what's going on. And the extra stuff is really it complicates your brain. So please keep that extra chatter to a minimum. So 1.7 meters per second, fantastic. Now, that's only half of it though, because I also want to know it in kilometers per hour, right? How do I do that? Somebody walk me through what you did to solve that problem? Start calling on people too. You can do it. Yeah.
You put 1.7 meters over seconds.
Okay. Like this?
Yes.
Okay.
And then you get rid of the meters.
How do I get rid of the meters?
You have to divide it by the meters.
What do you mean
Or
divide?
times it by the meters. Just put the meter on the bottom.
Oh, okay. So I just wanted to make sure I understood what you were saying. I think that you're communicating what I'm thinking, like this.
Yeah.
And then we're gonna put the meters down here.
Yeah.
And we're gonna put what up here? Okay, fantastic. So you were saying we're just words. Okay. So and then what numbers go in these spots? 1 kilometer. 1,000 meters. Fantastic. So that's gonna get rid of our meters. We also want it in hours, not seconds. So then we're gonna say, okay, we can either go from seconds to minutes, minutes to hours, or we can go from seconds to hours. I don't care. I'm gonna take it the step-by-step approach. So what goes up here? Seconds. And I'll put minutes down here. How many seconds are in a minute? 60. Bam. How many minutes are in an hour? Cancel, cancel, cancel. There's some more canceling. We do some multiplication. Before we tell an answer, how are we doing? Is there anybody that's still feeling okay? All right, what do we get for an answer? Who's got one? Back in the back corner there. What'd you guys get?
6.17 kilometers per hour.
6? Whoa. 0.17?
Yeah.
Awesome. Fantastic. Do we agree?
Yeah.
Excellent. Now, I had somebody that said, whoa, 6.17, that's huge. Because it's only going 1.7 meters per second. So why is this such a big number? Because of the hour, right? This is saying, so 1.7 meters per second, the units matter, friends, and this is what I want you to understand. That bowling ball travels 1 3/4 of one of these every second. So that's pretty decently fast, right? 1.7 meters per second is pretty I mean, you saw it. Do it yesterday. Okay? 6.7. It's 6.7 kilometers in an entire hour. Sit there for 60 minutes. Come on, bowling ball. Are you with me there? Okay? It's not like it's like going crazy fast. This is gonna take a whole hour. How are we doing? We okay?
Good.
Awesome. I love it. I love learning, especially on a Friday. It's a great thing. I want to wish you a happy National Toasted Marshmallow Day. If you something, if you need to celebrate, there's something to celebrate for today. I appreciate that you guys got your stuff. Today we're going to finish up the bowling ball activity, and we may also get to doing some definitions. My plan is for you to have this homework, page 45, numbers 1, 2, 5, and 6 for homework. We may or may not get there, so please stay tuned. Listen towards the end of the period. I'll let you know for sure, but this is my plan. I also want to apologize and kind of give a blanket statement. With 100 and some odd physicists that I have the opportunity to work with this year, it means that that grading quizzes and labs takes a little longer than like a one-day turnaround. So I apologize for that on the face of it. My goal is to get those back to you by Tuesday. So I just want to let you know that I haven't forgotten by any stretch. I just want to let you know that that's what's going on. All right. You have got graph paper in front of you. We are going to start making a graph. Please put the rulers down. You do not need to play with the ruler right now. Right now it is time to be graphing. This is the data that we collected yesterday. We didn't do a very great job of labeling our data table, mostly because we didn't have a lot of time at the end of the period. So let's put some labels on this data table, because I wouldn't want to turn this in as a data table to my teacher. They're the numbers. I don't know what they are. What do these numbers here really represent? The meter. So meters is a unit. What does it represent that's measured in meters? The what? I kind of heard something, but I can't tell. Hold on, friends. Shh. What did you say?
Like the 1 would be the first meter, and then the 2 would be the second.
Yeah. So it's like how far it's gone through those. Does that make sense? So it's the markers on the lane, but really for us, because they're each a meter apart, we're really talking about the distance that the ball traveled. Okay? And then what are all these numbers about? What's this business? I just see a bunch of numbers.
Times.
They're times, right? The time that it took to travel that distance. And measured in what units? Indeed. Okay? Just making sure that we've got everything labeled. And we've got 3 different trials. You have some graph paper in front of you. You're going to have the opportunity right now to graph that data. So go ahead. I need to tell you a couple things before you actually start graphing your data. Okay? Which of our variables in this activity was the independent variable? Independent, remember, means the thing that we got to pick, not the thing we measured. The distances are the independent variable. And what was our dependent variable? The times. Usually, big blanket statement, usually we put which variable on the x-axis? In the independent variable. The independent variable usually goes on the x-axis for an experiment, and the dependent variable goes on the y. Today, we're going to flip it. And the reason that we're going to flip it will become apparent later, but for now, we're just going to say, okay, and we're going to put the distance here on the y-axis, and we're going to have the label and the unit, and we're going to have time, which actually was the dependent variable. We're going to put that on the x-axis. I do not care if you have your graph landscape or portrait, like which way it's oriented, but it does matter that you have the distance on the y-axis and the time on the x-axis. Okay? As you're working through this, we need to set a scale next. What was our maximum distance? 10 meters. So we need to make sure that as you count up this way, you get to 10, and that 10 takes up most of the paper. What was our maximum time? 9.7 something? So maybe it needs to go to like 8 or something like that, all the way across here. Okay? What's that?
Would it need to go up to
It needs to go to 10 if it's 9.
Oh, yeah, I'm sorry. I don't know why I was thinking. I think I was looking at the 7. Yes, it should totally go up to 10. I apologize. 10 up, 10 over. Thank you for catching that. Last thing is when you graph it, how many colored pencils do you have? Try to shut that door for me. Thanks. 3. 1 each for each set of trials. You can pick which set of trials you want, like which color goes with which. If you want to stay consistent with me so that you can compare with what I'm doing, I'm going to use red for C. I'm going to use blue for E, and I'm going to use green for H. If you want to go switch colors, you're welcome to do that. If you're happy with the 3 you chose, that's totally fine with me as well. Okay? I'm going to give you a little time to work. Go ahead and turn your little push lights off and then turn them back on when you are set, when your graphs are in good shape. Okay? It's going to be a little bit time consuming. This is probably the most data that you will graph by hand in one sitting for the rest of the year, but it is important for today. Okay? Go ahead. All right. Other observations that you made? I saw hands before. Yeah, go ahead.
You said trial E was the fastest.
Trial E was the fastest. Now I'm going to poke you for just a second because I don't see anything up here that says fast or slow. So how did you know that trial E was the fastest?
It got to the 10 meters in a short amount.
Awesome. Okay. And again, the conclusion that you came to, oops, that is not up. Oh. The conclusion you came to is not wrong. It's absolutely right. But I want to make sure that as a scientist, you're leading everybody to how you're making conclusions, right? We're not just like making things up out of thin air. That's not what we do. So trial E was the fastest because it took the least amount of time to get to the 10 meters. Awesome. Other observations that you made, and it doesn't have to be about which one's the fastest, slowest, or middle. Other things. Yeah, add what you got.
The blue line, red line, and green line never cross.
Excellent. That's a good observation. So should I say we'll just say it that way. I like it. So blue, red, and green lines never cross. So I'm putting that lines in quotes because we haven't really established that they're lines yet. Welcome to our rulers here, right? In just a second. They do all kind of look like they are kind of linear. Linear means that they make a what? A line. Yeah. So instead of going joop, 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 we know because you watched the ball. When you watch the ball go down the hallway, I feel like I'm in a Dr. Seuss book. You watch the ball go down the hall. Did it speed up and slow down and speed up and slow down and speed up and slow down as it was going? Or did it just kind of go down the hallway? It just went. And so instead of connecting the dots, really what we want to do is make that line a reality. So you're going to take your ruler, okay? And instead of connecting, you're going to find what we call the best fit line for all of your data, okay? I think some of you did this in chemistry. Maybe you had a computer do it for you. You get to do it today. So the way you do a best fit line is you're going to line that ruler up, and not all the dots are going to be red on the line, and that is okay. Totally fine, okay? Get it so that you've got about the same number below as above, and then draw that line. And then do it for the other one and the other one. Go ahead and do all 3 of those best fit lines right now because they should be linear. And the data looks pretty close to linear already. So use your data points. Whoop, and make sure, friends, that you don't just connect the first dot and the last dot. Because if you just connect the first dot and the last dot, you may have missed a bunch of information. Okay? So set that ruler down and try and get a little bit above and a little bit below. And it doesn't have to be perfect, but do your best to line it up and draw a line that is the best fit for all of those points. Mine's not perfect. I probably should have moved it down a little bit, but it's kind of hard to do a ruler on the computer. I would probably move that down just a little tiny bit. But it's the process that I'm most concerned about today. Okay? So go ahead and try to get a best fit line for each of those sets of data. Will you have to do this again? Absolutely. This is good quality physics work here. Okay? Some of the data might be on the line, and that's great. But if there's some that's not, that's okay too. That's the nature of science. That's how it works when you actually are doing real science. Not all of the data is perfect. All right. Other observations that you made. What else do you see? Somebody over here, I don't remember who it was making a pretty profound observation earlier about these two data points. What did you say, Sam?
The ball, it said it went back in time, I guess.
The data says that the ball goes backwards. Now, you all were here. You watched it. Was there any of the trials in which the ball started going and then went backwards and then kept going? Did you see that? Like while it was rolling down the hallway, did it go back and then come down?
No, and it's weird because the time is going backwards.
Well, yeah, exactly. And that's what it implies, right? Is that time is going back, or it's at this point it's here and then it's coming. Does that make sense? Like it's something funky is going on, and I don't think anything weird happened there. What may have happened? What may have happened? What? Nope, friends. This is the thing. I get it. And 100% it was because of you. So in that way, yes, it is human error. But I don't want you to say that. And I'm not going to put up with it. Because you're smarter than that. You are smarter than that. I want you to talk at your tables and then we'll talk about it. But I want to make sure that everybody's engaged with it. What may have happened that caused that yellow business to happen? Look at it. Figure it out right now. All right, friends, we got just a minute. We got to do this. Shh. I'm going to go back first. Go ahead. Yeah. Any idea why there may have been more of an error in this one than in the green one?
Because the green one's going slower.
Yeah, the green one's going slower. There's more time. Right, they had all this time in the world. Where in the blue one, it was going crazy fast. Absolutely. So there is error because somebody probably missed their stopwatch, missed turning their stopwatch on or off. Okay? Please make sure before you leave that the rulers and pencils get put away. You do not have homework over the weekend. Enjoy your weekend. Be safe. Make good choices. Cheer on that football team. They're going to rock it tonight. It'll be great. All right?
Good choice, everybody.
Have a good day.